This is a sealed enclosure like you've never seen before. It has 6 12-inch drivers within a 3 cubic foot box. And in this video, I'm going to show you how I achieved over 145 decibels during an SPL test. And remember, this enclosure only takes up 15% of my cargo area in my 2018 Chevy Impala. So join me in this third revision of this passive radiator enclosure as I show you how I design, 3D model, and construct this unique enclosure. And later on, we're going to SPL test it and give some music demos. So sit back, relax, grab yourself a drink or a snack as we explore the unique power of the passive radiator. The passive radiator I'm going to be using in this build is by a company called Earthquake Sound. This is the Slaps M12 by Earthquake Sound, and this is part of their Slaps passive radiator series. This is a slim mount design 12-inch passive radiator with an overall height of around 3 inches. It has a mounting depth of 2¼ inches and it only weighs 2.75 pounds. Some more specs about the M12 is that it has an X-max of 4 inches. That's 100 millimeters for those viewing this outside of the States. It has an overall diameter of 12 3/8 and it has a cutout diameter of 11 3/8. So that's slightly larger than the 11 or so inch cutout that you see on most standard 12-inch subwoofers. That added surface area makes for some impressive results when you put this thing in a properly sealed enclosure, as you guys will see in an upcoming demo. But that's enough for now about the passive radiator. Let's look at the active drivers that I chose for this setup. The GW124 is a Gothic subwoofer by Power Acoustik, exclusively designed and marketed for Walmart customers. Power Acoustik have deemed this their premium Gothic series because it's a little bit different from the one that you can find over on their website. This one here actually features a 2.5 dual 4-ohm coil with a 1200 watt RMS and 2500 watts max rating. The dust cap of the subwoofer is adorned in silver and blue, and it has raised lettering right there in the center. Another signature look of this subwoofer would be the blue insert that cover its mounting screw holes and the silver basket that it comes equipped with. It has a high excursion rubber surround and a 254 ounce magnet motor. The GW124 has an FS of 32 Hertz. It has a cutout diameter of 11 inches and a mounting depth of 6¼ inches. It weighs 16 pounds, has a recommended port tuning of 30 Hertz, and a sealed enclosure recommendation of 1.25 cubic foot. As far as a ported tuning, they also want you to tune this around 34 Hertz with a recommended volume of around 2.5 cubic foot. Of course, in our case, we're going to be putting this in a sealed chamber, so we're going to stick to that 1.25 cubic foot net recommendation, and you'll see that next up when we plug these parameters in our digital design of WinISD Pro. Right now, we're over here in WinISD, and this is a tool that is used to virtually design speaker box and subwoofer box enclosures. So basically what you do, you come in here, you're able to input the parameters of the driver that you're trying to build an enclosure for. These parameters would come from the manufacturers. These are called TS parameters. And you would come in here and you would fill in mostly just the top part and a few of these. And it would auto fill or auto calculate most of these fields for you. This is very, very handy, very useful for especially a novice builder. What you want to do now is pay attention to the bottom left half of the screen. Down here is where you do all your manipulations. You can manipulate all types of data akin to the driver to change the response curve up here on your graph. If you look at the first tab, it says driver. We're only going to use, well, in this case, we're only going to use one driver for this vented enclosure, It's going to be a standard loading configuration on the baffle, not isobaric, and the voice cord connection is going to be parallel. If we go to the box tab, you'll see that I have a 2 cubic foot box for this subwoofer, and I have a tuning frequency of 32 Hertz. If we go to the vents tab, the vents tab will tell you based upon the shape of the vent that you want, whether that's an arrow port, it'll tell you what diameter and length that arrow port needs to be. You can manipulate this into centimeters, meters, or millimeters. In our case, I'm doing inches because I'm here in the state and we do inches and feet. We're going to actually use a rectangular shape. This is going to be a slot port design, so it's going to have a height and a width. The height is going to be 16 inches and the width is going to be 1.75 inches or 1 3/4 inch. Going to give you a total vent length automatically calculated to 33.5 inches, and it's giving you a cross-sectional area of 28 square inches. This is very, very important if you're trying to stick to the manufacturer's specification or if you're trying to follow a design that you would maybe have purchased or gained from someone else. Filters, we're not going to set filters here, though you can add filters if you want to. You can add a low pass filter depending on, if you're setting up a different configurations, maybe a 2-way system, a 3-way system. You can come in here, you can do a high pass system, a high pass filter as well as an all pass, length, width, parametric, EQ, you name it. This tool is very, very handy and can do it. We're not setting filters, so we're going to go to signal. In this case, we're talking about the listening place. I've learned from previous experiences with this tool that in my car, if I set the listening distance to 1/2 foot or less, then this will give me a better representation on my SPL graph that we can also come up here and look at. It gives you the same frequency at the bottom, decibels on the side. Right now it's saying that around 40 Hertz or so, I can get 140 dBs out of here at 2500 watts of input. Okay, so right now what we've done is added the passive radiator build to the graph. The passive radiator build is represented on the screen by the yellow curve here. As you guys can see, this yellow curve is actually a lot higher tuned than the vented enclosure, and that's for a reason. This is meant to be a very musical enclosure, even though passive radiators have been used in most cases to get a lower tune frequency, like in home audio theater systems and whatnot. This is going in a vehicle, and the person that's building this actually wanted this to be a musical box. So what we're going to do is tune a bit higher in order to get those transient bass responses and to get a higher output with more moving cones. So in this case, we're going to use 2 drivers, and this is going to be a standard loading configuration on the baffle. This is not going to be isobaric, okay? The box it has a volume of 2.5 cubic feet, and it has a frequency tuning of 38 Hertz. The passive radiator we are using is going to be 4 of them. And in case you guys are wondering what kind of passive radiators these is, the passive radiators are called the Slaps passive radiator. This is the Slaps M12 passive radiator by a company called Earthquake Sounds. We're going to be using 4 of them, and each of them is going to have a 260 gram mass or weight added to the cone. As far as filters, we're not going to set a filter here. As far as signal, we plan on putting about 5,000 watts through this. This is the combined or total max rating of the subwoofers, the active drivers that we're using, the Gothic subwoofers. They are 1200 watts RMS, 2400 watts peak, meaning we can get about 5,000 safely through them. And this is what that response curve is going to look like. If we take a look at the SPL graph, you can see that the Gothic PR setup is saying that it should peak out at around 147 decibels at around 48 to 50 Hertz. So this is a high tuned box, This is more of a classical, higher tune, very musical type enclosure. But once again, the box has an internal volume of 2.5 cubic foot net, and we have a tuning frequency of around 38 Hertz. But right now, what we're gonna do is move on to SketchUp, where we're gonna use all the information that we gathered here to 3D model our enclosure. All right, so right now what you guys are looking at is the trunk space of my 2018 Chevy Impala. This is a 3D rendering of it, and I just wanted to kind of give you guys an indication of front versus rear facing in the trunk space. I have my subwoofer amplifier mounted on the driver's side within the trunk, and this is why it's denoted front back with the fingers pointing. Next up, what you guys are gonna see is a blue shading on the screen. This is the internal volume of my trunk space. 2018 Chevy Impala has a little bit over 18 cubic feet of cargo area in the trunk. And this right here is a shading that is representative of the enclosure that I'm about to build. This enclosure has a total volume of around 3.37 cubic foot. It's not a very large enclosure, meaning that passive radiators is basically built to save space, and this would be a prime example of that. This is going to be housing 6 radiators, 2 active and 4 passive, and you only need 3.7 cubic foot. That's total volume of the enclosure. And as you guys can see, this only uses around 15% of the available cargo space, which means that this saves you about 85% of trunk space. Again, this is 6 cones, speaker subwoofer cones, moving inside of your trunk when you're only taking up 15% of it. And you get basically to keep all your trunk, and you have room for groceries and luggage. Pretty amazing passive radiators. This is the actual enclosure that is going to be built. This is the wood construction of it. The 2 holes on the top up here is actually going to be for the active driver. They're going to be firing upward, whereas the PRs are going to be firing toward the trunk and toward the side panels. So they're going to have a loading barrier of side panels and trunk, those hard spaces to load off of, while the active drivers are actually going to be firing off the lid. Right now, what you guys are looking at is the internal volume of the enclosure. This is your net volume after displacement of port bracing and subwoofer. You should be left with about 1.25 cubic foot per chamber after displacement. So this subwoofer is going to have this much to work with, and the PRs as well. And if you do your if you go look up the documentation, you will see that these subwoofer PRs, or passive radiators, actually work really, really well in tight spaces. I think they said down to half a cubic foot, these things can still be optimized to perform in. As far as the subwoofers themselves and sealed enclosures, I think they have a recommendation down to 1 cubic foot. I believe that it is. But just know that even though this looks small to you, I look at this as being a sealed chamber. Some people, of course, would say different. There's a 2 school of thoughts when it comes to passive radiators. Some people would say that this behaves like a port, and that the moving of the cone is like the movement of air in a port. I beg to disagree, but hey, leave a comment in the sections below. Let us know what you think about this. Is a passive radiator system considered to you ported system or a sealed system? Let us know in the comment section below, and we'll talk about it there. Right now, what you guys are looking at is a 3D rendering of what the final setup is going to look like. Right now, you have like I stated earlier, the passive radiators are to the side and the active drivers are to the top. And of course, the drivers that I'm going to be using in this is the GW124s by Power Acoustik. That's their Gothic series that they prioritize for Walmart customers. Next up is going to be build and assembly. And after that, we're going to do installation. This enclosure has proven itself to be a great performer, so it's only right that I treat it right. So what I'm going to be doing in this little piece right here is actually getting some carpet, wrapping this boy up, giving them that more finished look that it deserved and has earned. So the next time you see this enclosure, it'll look a little bit more off the shelf, I should say. And just in case anyone is wondering, this is simple felt material that I got from the local Hobby Lobby. This is not going to a customer, so there's no need of spending extra money on automotive carpet. But enough of that, it's time to get this thing wrapped up, put it in the car, and we're gonna get some music pumping through it. I ran into a slight issue, and I'm glad I caught this early on. Right now, what you guys are looking at is the top of the box, because this is a upward firing enclosure. And typically you wanna keep your dust cap emblems or symbols that you see here, you kind of want to keep them symmetrically and you want to keep them in line, right? So these are pretty much running where you can read them left to right, just like any other piece of text that you would see in a book, on a sign or whatever. But in this case, the issue is when you come on the inside. And because this is such a small enclosure, you can see here where the issue lies. If you look up here, you will see that the passive radiator, which is also positioned like this, is actually, it would actually be in the way of the terminal that you see right there. That's the speaker terminal. And as this thing flexes in and out, which it has a 4 inches of mechanical travel, it's definitely going to be hitting that terminal and probably break it because it's made out of plastic. So what I am going to have to do is I'm going to have to position those terminals out of the way of, I'm going to have to position it out of the way of that. I can probably put it like this because I want it where when that thing flexes in and out, it's not going to hit anything, right? That's the goal. So right there, I believe we'll have the better chance of that passive radiator being able to flex in and out without, hitting anything. And if you guys remember from the last video that I did with these passive radiators, I actually broke one of them because in what I believe was an incident where the weight on the back of the passive radiator actually was slamming against one of the magnets of the other subwoofers that I use in here. So the reason I'm using these subwoofers here today is because they're a lot more shallow than the last subwoofers that I use, and the magnet doesn't extend. It doesn't have that mounting depth to where it'll hit this screw protruding out of the center of the passive radiator. So I think we'll be in better shape by using this setup than we did with the larger subwoofers from NVX. So I think if you got some relatively shallow subwoofers or just a cheaper subwoofer with a smaller motor on it, you'll be perfectly fine if you're trying to duplicate what you guys see here today in this setup. So if you want to get this setup going, just keep in mind the positions of your terminal in relation to the flex or mechanical travel of this passive radiator. And as you guys can see now, this is going to look a little bit odd when you guys see the actual video because the emblems on the dust cap is going to be turned that way. So the logo looks a bit weird. But if you guys see this, just now you know why it's turned like that. It's not going to be, give you that perfect legibility, left to right. It's going to be looking a bit diagonal. So. Okay, so a little bit about the wiring. These subwoofers are dual 4-ohm subwoofers, meaning that the lowest impedance that I can get out of them would be 1 ohm because, well, each individual subwoofer, the lowest impedance you can get is 2 ohms, right? So I'm going to wire them down in parallel. Each subwoofer is going to be in parallel to 2 ohms, and then I'm going to wire them together in parallel, and that's going to bring it down to 1 ohm. Remember, with series and parallel wiring, you're doing two different orders of mathematical operation, okay? The first mathematical order of operation is going to be division, and the second one is going to be multiplication, okay? So let's talk about that. Parallel wiring. When you do parallel wiring, you're taking 4 ohm and 4 ohm, and you're going to divide that by however many cores you have. So in this case, we have 2. So 4 ohm and 4 ohm. So we have a 4 ohm, and we're going to divide it by what? 2, which is going to give you a final impedance of what? 2. So if we did this in series, the order of operation that we're going to use is multiplication. So if we have 4 ohms and we multiply that by however many cores we have, which is 2, that's going to give us a final impedance load of what? 8. 2 times 4 is 8. Very, very simple. And in order to do so, what we're going to be using is, for one, let's look at the terminal here. This is the terminal that I'm using on my speaker box. It's a single terminal, negative, positive. Internally, what I've done is I've ran 2 wires to each of those connections. Let me give you some light. So we have 2 wires ran to each of those connections, and they're split. See how I got that? Show you why I did that. Coming off that split is a positive and negative run. Each of them are like this. And then I split it again. Positive and negative run. This is going to go to each of the subwoofers are going to be wired the same way. So just pay attention to what I do here, and it's going to be done the same way to the other one. So we're going to take these wires. This is a single wire with a little splitter on the end of it. Positive and negative is split and shared, and we're going to put it in here. Give me a moment. And this is what it looks like. Very, very simple. Now positive and negative have a wire inside of it. Coming off here is going to be its corresponding positive and negative wire. So what am I going to do? I'm going to take this wire, positive and negative, and this wire is just going to go to the other side. I'm going to jump to this side of the subwoofer and do positive and negative once more. Very, very simple. Negative goes here in the negative terminal, and positive goes here to the positive terminal. Very, very simple. Now you have your positive to your positive and your negatives to your negative. Very, very simple. It's not hard. We're going to do the same thing to the other subwoofer. And just to double check to make sure I didn't mess up nothing, we've already gone and probed the speaker terminal, and we're going to turn this on and see what our impedance value is. The impedance symbol is denoted by the little horseshoe symbol right there. That's your ohms symbol for resistance. So we're going to turn that on, and we're going to watch the meter. 2.4 ohms is what it's reading. 2.3, 2.4, probably going to change every time I say something because the cone picks up on environment variables. It's as far as noise from the outside world. As long as it's close to 2 ohms, you've done something right. So we're going to do the other one, get this thing installed, and we're going to pump some sounds through it. All right, so before we get too far ahead of ourselves, what I want to do now is make sure that the polarity of these things are correct. You don't want them to be playing out of phase, meaning that you don't want one going up and the other one going down. You don't want this. You will get no sound like that because nothing's being pressurized, right? So what we want to do is make sure that the cones are moving synchronously, right? We want them to move at the same time in the same direction. All right, so let's get that tested. This is my negative, positive. And that's what you want. As you guys can see, they both move upward at the same time. That's the direction we're looking for, and that's definitely the synchronous that we want. We don't want this. We want this, right? Yeah. And it moved upward. But even in your case, if it would have moved downward instead of upward, that still is an incorrect wiring. So you would have to go back in there and pretty much just reverse your negatives and positives. You know, that happens sometimes. We get in a rush and we mess things up. Anyway, hope this can help somebody out. If it did, share it with a friend. So I finally arrived to my favorite spot, and then disaster strikes. This is when I got the biggest disappointment of this entire build. You won't believe what happened. Something sounds loose. I think it's one of the PRs. Let's check it out. Turn it down a little bit. Let's turn it down just a little bit. Yeah, sound like we got a loose PR. One of them loose. I can't tell which one it is though. I want to say it's this one. It's this one or that one. One of them's loose. This one? I hope it ain't the sub playing, but I don't know. All right, here's another song. We'll see if we can tell on here. I think it's this one. That weight may be loose on the back of it. If I hold it. See that? If I hold it, you don't hear it. Now that's clean bass. But if I let it go, you hear all that rattling. It may have cracked it, or it may just be loose on the back. The weight on the back of it just may be loose. Everything else seems pretty good, solid. But this one over here, making a lot of noise. See that? You don't hear it. And that's the only one. I don't know, it may be a mounting thing, I don't know. That's what they look like. Boy, does it ever sound so good. Watch when I close the trunk. I'm gonna turn it up. Now I know it ain't the sub. Gonna bump it. So sad that PR did that, but it's not designed to take all that power. These Power Acoustics can really throw a lot. They sound good in a sealed box. If I hold it, it's this one. Yeah, I done tore it up. Crazy. Crazy. Got the trunk about to jump off the hinges. Crazy. Crazy. I'm gonna give it a rest. I'm gonna give it a rest because I know the PR is not taking it. It's too much power for the PR. You can't overpower these PRs despite them having a 4-inch X-Max. Mechanical travel peak to peak is 4 inches, though you can overpower them in an application such as this. Very small enclosure, whole lot of power. You can definitely tell something, and I think that's what I've done. So we're gonna give it a rest for now, and I'll see you guys in the next one. And if anybody's wondering what I got powering these things, it's the default amplifier that's suggested by Power Acoustik. That is the Razor 2500D. That's their Razor series. This is the one that is recommended for these two subwoofers right here, and they pound. You guys see it for yourself. I'll be metering them later on to see exactly how much power they're actually getting to these subs, but in my opinion, it doesn't even matter. It's moving them like this. No, you don't need a PR setup like I got. Passive radiators are not even recommended for these subwoofers, but they work. If you guys want to spend a little extra money, there you go. You have a small footprint, small box, and a big sound. That's all that matters. All right, so the goal is right now is to get this out of here and check on that passive radiator over here. So I'm going to get this box spent around, see if I can get this guy out of here and see what's wrong with it. Okay, so I had this thing out and I don't see any cracks or anything in it. Seems perfectly fine to me. I don't know what that sound could have been, unless it was coming from the sub itself, which seems pretty solid, man, but you never can tell unless you get it moving, right? But let me look at something right quick. Can I turn this with my hand or not? Oh, ever so, okay. Yeah, that ain't good. That can definitely be an issue. Let me check the gasket on there right quick. So basically what you want to do is get a socket, wrench, or something that can hold this while you turn this nut back here. Okay, I did put a locking nut on here, a locking washer on here, but for this type of force, I may need to put that second nut back on here to keep it from moving at all. But for right now, that's what you're gonna need in order to tighten this down. So I got, what is this? This is a 14 mil. And then on the other end, which would be approximately the same size. So they're the same size, basically. But I only had a 9/16. So that's what I'm using, 9/16 or 14 to get you there. All right, so I gotta show you guys the final install of this and what I did different, right? All right, so as you guys can see right now on the front of this, you have a large washer on the front. And I'm gonna tell you why I did this. If you guys can look at this, you can see that there are some stress marks. Not stretch, but stress marks. I want to call them fractures, but that's not an open right there. That's just a dent that it's making because it only had originally the nut, the bolt, and the head of it is too small. It's not enough surface area here to compensate for all that pressure and stress that is being built up on that one area. So what I did was just broadened it by adding a washer right here. And this right here actually, to me, it sounds better. I don't know, maybe that's all in my head, but it definitely secured it. I don't get any more looseness out of it, no more rattling. Another thing I did on the rear of this was I took away that lock washer. I don't know. I don't know what I was thinking when I put that on. I do know what I was thinking. I thought it was a better option because getting the double stacked nuts off was very, very hard because it had locking solution on it. So in short, this is what I did. I'm going to use this bolt right here as an example. So you first want to load it. Remember, there's a hole in the passive radiator, and you want to load it like this. So I took a washer, which you see right here, and I stuck that onto it first, put it on the face of it like that. On the other side, originally the way that it came, it had two nuts like this stacked on top of each other. And the way that these nuts work is that they will secure, remember the passive radiator is like this. They will secure down till it hits the passive radiator, then you would tighten the top of it. Okay, put some lock thread on it, some thread locker on it, whether you use blue or red. Blue I believe is non-permanent and red is permanent. I added a washer, and the first attempt was to get rid of that screw, replace it with one of these. Don't laugh, all the guys that know better. I replaced it with one of these, and then I just screwed one of these down on top of it, and I called it a day. Well, you just seen that ridiculous demo I tried to give y'all, and that didn't work well at all. So what I did, I came back, you guys seen me playing with it and seeing what to do. So what I ended up doing was getting some of these guys, the nylon lock nut assortment. So the lock nut with the nylon in it, see that plastic at the tip of that nut? It has that plastic in there. And that plastic material right there is nylon. That stuff is strong. And you have to put some force on that nut in order to make it screw down onto the bolt. It doesn't cut easy. And that way it can withstand a lot of vibrations, and it locks onto it just by using that material right there. Plus, you know, the normal tightening of the nut, of course, that's going to tighten as well, metal against metal, right, in that corkscrew fashion. But when you add that nylon, that's a whole nother game changer. So what I did, like I told you, I got rid of this. Don't use this. It's not for high vibrations. I put this guy on here first. I wanted him on that PR, so I put him down on the PR, the cone of the PR, just like that. And then I just took the original screw that they had to lock it, and I locked it down with this. And that's the best way that I see fit for this application with what I have on hand. And I've sent thousands of watts through this system, and it has yet to come loose. So in case you guys are wondering, hey, you know what those things on the front of the PRs, that's what that is. And if you know a better way, an even better way of doing it than what you see me doing here, leave a comment in the sections below and we'll talk about it. Another change I want to talk about with the setup is the way that I have them chambered. Originally, when I did this, the chamber had a hole, well, it was a very small hole in it to run wires from one sub to the next, because I only have one terminal. So I was running the wire from this sub through the dividing wall in there, the brace, into, you know, this chamber. But what ended up happening, I got a lot of comments like, hey man, plug that hole, it'll get a better, you know, response, it'll sound better, things of that nature. So I did that, and I'd be dang, man, you guys were right. They actually do sound better. So let me do this. Let me do this for you. I'm going to give it a press test, and you guys are going to see that PR is not going to move. That speaker is not going to move. But these two here are going to move. So you guys can get a better shit. You can see that. Okay, here we go. I'm going to press this, and you're going to see that these ones over here are not going to move. And as you guys can see, these two are only moving and not these two. I wish I could, what I could have done differently here is seal the PRs a lot better, because they don't really got a lot of gasket right here. And this gasket is very flimsy, just being honest and transparent. It's very flimsy. What I should have did was took my shop mat and made a gasket for it and sealed them better. Because as you guys can see, the subwoofer it resets to 0 very quickly, and that's because the PRs are not as airtight as they could be. So if you're watching this and you're thinking to yourself to build something like this, just know that if you seal these things off, your response will be even better than what you're going to see in the video. You see how fast it rebounds back to 0? You don't want that. When you press it down, it should come up very slowly on a properly sealed enclosure, because the screw holes are always going to leak unless you go through extra measurements of putting wood glue in there when you screw them in. And I don't do all that. Then when that thing is moving up and down at 50 and 60 cycles a second, that little air leak is not even going to make a big difference. But with the air leak I have, it is going to make a difference because the rebound is too quickly. You see that? I mean, it's not an instant rebound, but it's coming up a little bit quick, a lot quicker than I want it to. But anyway, that's another tip. Just wanted to share that with you guys before we move on. Okay, so as you guys can see, we're back here in the Impala, and today we're going to be testing the passive radiator build. The passive radiator build is actually turned facing the trunk right now. It's going to be using that trunk lid as a loading chamber. And for everyone who's new to this build, or those who skip straight to the demo, that is a 4 passive radiator, 2 active driver setup. So the enclosure is a very small enclosure, and the purpose of this video is to show the perks to having a passive radiator build. Powering this setup, we have this Taramps Smart 8 base. That is an 8,000 watt RMS subwoofer amplifier, and it delivers those 8,000 watts RMS with variable impedance ratings. The impedance ratings that it can deliver that RMS rating is going to be in between 0.5 ohm and 2 ohms. Very smart technology. And to measure how much power we're going to be getting from this amplifier, we're going to be using the SMD AMM1. The SMD AMM1 is an audio multimeter, and this multimeter actually has what is considered a dyno mode. The dyno mode actually gives you the peak power that the actual amplifier has put out at a particular impedance rating. So it gives you the impedance value on top, and you get the wattages on the bottom. Like previously stated, this is a SPL demo, and to measure our SPL levels, we're going to be using the mini base meter by SPL Lab. SPL Labs created this little guy so it can have a more mobile or more mobile friendly application. So you can transfer this thing into any vehicle without a laptop or a computer, only using this little dongle that they sent with it. This is what's powering it right now. You can also power it from your cigarette lighter outlet in your car if you have one of those. So what we're going to be doing is measuring our SPL levels with this little mini base meter, and it's going to display those values on screen in the units of decibels. That's what you measure sound pressure level with. All right. In order to get this jumped off, we need to find our cabin peak. And to do so, we're going to use this Android application. This Android application, we're going to be using a bass sweep from 150 hertz down to 20 hertz for 30-second duration. We're going to turn the volume about midway. Around here, we're going to turn our bass knob all the way up. Around here, and we're going to conduct our bass sweep. So let's see how much power we get and what frequency we peak at. Whatever frequency we peak at, that's what we're going to burp it at. That's what we're going to test at. 150 hertz. Let's begin. 20 hertz. All right, so let's see what value we got. We got 128.3 decibels on the meter, but that's not what we're worried about. What we want to know is at what frequency it got that reading. So let's go here. 48 hertz. Remember, this is a sealed enclosure, so 48 hertz sounds about right. All right, so the application's calling for 48. We're going to test at 48. Woo, door speakers are loud. Let's turn up the bass, baby. It's 2,500 watts. We can do better than that. Let's turn it all the way up. I know y'all just seen that. Anybody that's been watching this channel for a while know I can't stand this damn meter. I mean, I love the meter functionality, but it has this auto turn off feature that does it in just the worst case scenario. You guys see I got my battery is good and everything. We don't know what our power time, how much power that was. So we're gonna have to run that again just to give you guys that value. Dang. All right. So let's turn this back down. I don't even want to look at this. We got a 144.7 in the kick for anybody wondering, but we need to turn this thing up again. All right, so here we go, 48. Woo, that's loud. Woo, snap. 5,476 watts at 2.1 ohms of impedance. I heard them bottom out then. I don't know if it was the passive radiators or what. That's a 145.2 in the kick. 145.2 in the kick. Let's let the window down for one time. We'll get it going again. Man, I don't want to damage nothing. That's over 5,000 watts of power. 5,000 watts of power. Let's see if we can beat that score. If we can best that score, then we're gonna get out of here. That's a lot of power. I shouldn't have took them that much, but I did. Let's go. Let's reset. So we got 4,676 watts at 2.1 ohms of impedance. Ooh, man. 145.2. Look like the same score. Let me let this up. So I ain't gonna mess with it no more. That's it. 145.2. All right, so that was fun. But what does this thing sound like on music, right? I mean, that's the reason why most people put subs in their cars, to see if it's gonna enhance the quality of it, the way it sounds, right? So that's what we're gonna be doing right now. We're gonna be playing this one song that I like by a guy named Xavier Russin. I don't really know how to pronounce that brother's name, but that's the name of the song, Dividend Yield. And they got a very dynamic beat, and I think it allows the performance of this enclosure to actually shine. So that's what we're going to be doing. We're going to be pumping some sounds through it, and we're going to see how loud we get on music. All right, so let's go ahead and reset the meter, and we'll get right back. All right, we have the meter reset, and we're going to be playing Dividend Yield.
Look, baby, I'm way too high to be worried about what a nigga say about me. I'm way too fly to be coming down, dishing out game for the free. I'm way too fly not to go and run the numbers up and hit them with a fee. You way too dry to be hating on the dripping nigga who they wanna be. I'm ready, my partners, I'm too activated now. They know that I'm popping, I ain't
I'm not even gonna pretend like my speaker didn't just pop out the magnet. So let me turn this down and just give y'all a real shot.
Baby, you know how to play it. I don't speak a lot, but I just mean it when I say it. You another threat, I got the game face on. Even though you greet me with your stank face on. Nigga, quit the capping with your gang bang song. You ain't never hit the block and take place on. Moving with the mission, had to cancel out the clutter. Quarantine, clean, two-step.
Let's put a little bit more power through them.
Hit the low side, had to tap in with the brothers. I'm way too high to be worried about what a nigga said about me. I'm way too fly to be coming down, dishing out game for the free. I'm way
Put a little bit more power to them.
too fly not to go and run the numbers up and hit them with a fee. You way too dry to be a driven nigga. Wanna be, I'm running up my partners, I'm too activated now. They know that I'm popping, I ain't had to say it now. Play around.
All right, so what do you guys think about that? You know, to me, it's a really clean sound. That's what I like about it the most. It's a very, very clean sound. I love it. And I think anyone who would make the purchase would love them too. Of course, you don't need 4 passive radiators like I have, but if you want to get a little bit louder with the passive radiator, then you know you may want to have a setup like mine. But remember that a passive radiator is just to enhance the low end that a sealed enclosure sometimes lack. So you don't have to go extreme like I did. But you know, if you want to go and save some space in your trunk, have a smaller footprint, and put out some quality bass, some quality low end extension, this will be the way to go. I will always vouch for a good passive radiator setup. You can't go wrong with them, you know? Like I said, space saving, you don't need a whole lot of energy, a whole lot of power to push them. I'm pushing a lot of power through them just for a stress test to kind of let you guys see what you're getting yourself into. But just know that you don't need as much power as I have. But anyway, leave a comment in the section below. I'm headed to the house, I'm hungry. My wife didn't cook. And I gotta go eat something. But leave a comment in the sections below what you guys think about that. Would this be something that you put in your car? Do you think passive radiators have a place in car audio? Leave a comment in the sections below, and I'll see you there. Thanks for visiting the channel to help you simplify car audio. It's the Budget Basshead, and I'm out.